In this video, I'd like to take a look at where the quadratic formula comes from. I want to take the general form for a quadratic equation, and I want to use the process that we know how to solve this type of equation called completing the square, and do that on this. Now before we do that, I want to talk about how to complete the square when we have numbers in there, because that's something we're familiar with. And we're going to see how those steps in solving this equation are going to follow over to the steps to solve this equation. So the first thing that we would do when we're completing the square on an equation like this is make sure there's nothing in front of x squared. So I want to make sure that that 2 is gone, so we're going to go ahead and divide by whatever's in front of x squared. So we're going to divide both sides by 2. That's going to give us x squared plus 6x minus 16 is equal to 0. The next thing we would do is we want this to be a perfect square trinomial. So we want this to factor to some binomial squared. And so we need this third number to be a specific value, and negative 16 just isn't it. So let's get that out of there. Let's go ahead and add 16 to both sides. So we have x squared plus 6x. Now I've got a blank space where we can put that third number, what it needs to be. On the right we have 16, and we're also going to be adding something to the right side. The next thing we do is to figure out what that value needs to be a perfect square. So bring down that middle term, divide it by 2, get 3, and when we square that we get 9. So if you add 9 to this side, now it's going to factor. That's a perfect square trinomial that will factor to x plus 3 squared. Remember, it's going to factor with whatever that was when you divide it by 2 is going to be in your binomial. And that is equal to 16 plus 9, that's 25. Now we're able to take the square root of both sides, and on the left side we have x plus 3, and on the right side we have plus or minus 5. Last step is if we subtract 3 from each side, we're subtracting it from positive 5, so 5 minus 3 is 2, and we're subtracting it from negative 5, so negative 5 minus 3 is negative 8. And those are our two solutions. So we had to divide by what was in front of x squared, then we had to move that c term over, divide that by 2 and square it. That got added to both sides. That allowed us to factor it as a perfect square. Take the square roots, make sure you have your plus minus, finish solving, and you're done. And that's what completing the square is all about. Now what I want to do is take a look at those exact same steps, only instead of numbers we have variables in this equation. Now we know what the quadratic formula is supposed to look like. It's this: x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So what we're going to do is all the same steps of completing the square that we did here, we're going to do that on this equation, and we should see that in the end it'll come out to this. So let's think. What's the first thing we did over here is we divided by 2 to get that x squared by itself. So that's what we're going to do here. I don't want that a, whatever it is, in front of x squared, so I'm going to divide both sides by whatever that is. A divided by a is 1, so we have 1x squared. B divided by a, we don't really know what that's going to be, so we'll just leave it as b over a, x. And c over a, we don't know what that is either, so we'll leave that as c over a. And 0 divided by a is just going to be 0. The next thing we did is we subtracted over that c term, so we had to get rid of that, move it over. So I'm going to subtract c over a from both sides to open up that space. So we have x squared plus b over a x. Now I've got a blank space equals negative c over a. And we're also going to add that to the right side when we figure out what it is. Well, here we had a 6. We divided it by 2 and squared it. And that's what we're going to do here. b over a, let's divide that by 2, and that becomes b over 2a. If we square that, we have b squared over 4a squared. And that's what we need to add to both sides, b squared over 4a squared. Now just like over here, when this factored to x plus 3 squared, this is going to factor with this in the binomial, so we'll have x plus b over 2a squared. And that's going to be equal to what we have here. Now I'm not a fan of those two fractions being separate. I'd like to combine them if I can. So what I need is common denominators. I could add these together if they both had a denominator of 4a squared, so I need something down here. If I take negative c over a and multiply it by 4a on the top and 4a on the bottom, I'm going to get negative 4ac over 4a squared, and now I can combine those together. When I combine these, on top I have b squared minus 4ac, and on the bottom I have 4a squared. Over here, once we had it factored, we were able to take the square root of both sides, and that's exactly what we're going to do here. I want to get that square out of there, so I'm going to take the square to the left, take the square to the right. On the left side I have x plus b over 2a. On the right side I have a plus minus. Now the top I can't really simplify, so I'm just going to leave that as b squared minus 4ac. But the bottom can be simplified. That's going to be square root of 4 is 2, square root of a squared is a. So I have that over 2a. Last thing I want to do is subtract b over 2a from each side. And that's going to allow me to get x by itself. And so on the left side I have x. On the right side, common denominators, I can combine these together. So let's put that negative b first, plus or minus the square root of b squared minus 4ac second, and that's all over 2a. So all we did here is the exact same steps as we did here. We completed the square. The only difference is we didn't know what these numbers are. So we completed the square with variables, and what we ended with is that famous quadratic formula. And that's really what algebra is all about, is taking numbers that we don't even know what they are, working with them, and finding something meaningful in the end. So I hope that helps understand where that quadratic formula comes from in the first place.